number of participants starting to increase. Many people also go through YouTube.
Or they will join in slowly because, like I said, no, in India we had the celebration, and even I had a small evening tea at my colleague's place because today is holiday here. Otherwise, yesterday and day before it was working day, so we celebrated Diwali today. So like that, people will be, because in our community, a lot of Indians are there. That's why. Yeah, slowly it's increasing. We generally have up to 50 participants.
Yeah, this time we have 100 registrants from different countries, and many more will be watching over YouTube.
Nandini, maybe you should start.
So we'll start. So welcome everyone to the 5th webinar of ONWARD. ONWARD is an open network for water-related diseases, a project funded by Global Challenges Research Fund UK, and it is dedicated to developing a network of scientists and stakeholders sharing a common interest in better understanding of environmental controls on outbreaks of water-related diseases, then the role of society in countering it, and also in forecasting, early warning, and risk mapping of water-associated diseases by using through remote sensing, field observations, mathematical modeling, etc. So in order to improve our knowledge about these and also to build the network, we are organizing a series of webinars, and this one is the 5th in our series. And now with these, let me introduce today's speaker, Cristiane Girotto. Hello, Cristiane. She'll be speaking on analysis of environmental factors supporting recurring cholera outbreaks in Sub-Saharan Africa. And
everyone, hello, good morning, good afternoon, good evening, sometimes depends where you are.
Yeah, and Cristiane is an engineer. She's a civil engineer. She's a graduate in civil engineering from Brazil and civil and environmental engineering from UK. Then she did her MRes at University College of London, and it is her thesis work that she'll be presenting now. And at present, she is a PhD student at the University of West London in UK, and she is now working on artificial intelligence applications on sustainable drainage system. And this is mainly because the project that she was working on, the Overcome project, it was a collaborative research working on digital innovations in flood early warning and water-related disease prevention for community capacity buildings and resilience. So we have Cristiane, who is working in almost close lines with our work. So let us hear from her.
Okay, we're going to start a recorded presentation, but I'll be able to answer your questions afterwards. If you have any more questions that I can answer today, you can just leave them and I can come back another time to answer for you.
Yeah, while she is putting up her screen. Those who have any questions, please post them in the Q&A box.
So welcome to today's presentation. I'm going to talk about analysis of environmental factors supporting recurring cholera outbreaks in Sub-Saharan Africa. I'm Cristiane Girotto, and this presentation is part of a master's degree, research degree in urban sustainability and resilience at the Department of Civil Environmental and Geomatic Engineering at University of College London. Cholera in Sub-Saharan Africa. Africa struggles with cholera since the first pandemic. Recent research attributes 83% of cholera deaths between 2000 and 2015 to the Sub-Saharan region. The main risk factors on Africa's cholera outbreaks, according to this study, are conflicts. Conflicts in Africa have a direct relationship with cholera outbreaks. The inhuman life conditions resulting from conflicts can dramatically favor disease incidence. As an example, the Rwandan genocide, where 850,000 of its 2 million refugees triggered the 1994 cholera outbreak in the city of Goma in the Democratic Republic of Congo, killing thousands of people in the city and particularly in the refugee camps. Similar cases happened in Mozambique and Angola during the civil war against Portuguese colonizers. The return of 400,000 Angolese refugees triggered Angola's sleeping outbreaks in 2006. Not just the refugee situation, but also the destruction of infrastructure and basic living conditions offer great conditions for the disease spread. Public policies along conflicts. Public policies notably impact performances of African countries on cholera control due to the lack of investment, along with privatization of water provision, culminates on restricted access of clean water for the poorest segments of the population in several African countries. The geographical localization plays a role as cholera cases are significantly higher near lakes, main roads, harbors, and railways, as well as coastal areas, and vulnerable to cholera importation due to large population movements by sea, road, rail, or air, and other in boats and ships that brings cholera from other countries. Water and sanitation. The World Health Organization established that there are 4 essential interventions to prevent the spread of cholera. They are safe drinking water, adequate sanitation, personal hygiene, and food hygiene. But it's worth mentioning that personal hygiene and food hygiene are directly related to safe water provision and sanitation. Hygiene is not just a matter of education, but is fundamental to have easy access to clean water and sanitation to allow the practice of basic hygiene habits. Water and sanitation links with cholera are supported by numerous scientific publications, which just makes sense as cholera is a waterborne disease. For decades, the scenarios of Africa waters and sanitation provision has been accompanied and reported. The UNICEF and WHO reports, World Health Organization reports, show that in the year of 2000, almost 40% of the whole African population had very limited access to drinking water and used unimproved or surface sources. It took 17 years to improve this number to an average of 30% in 2017. It took 17 years to improve 10% of water provision in the African countries. Regarding sanitation, most residents in the sub-Saharan cities use on-site facilities like pit latrines and septic tanks. Those facilities are scattered and not connected to a sewage system. Reports on sanitation shows that 54% of the continent's population used unimproved facilities or open defecation by 2000. And this number improved to 40% in 2017. Again, just an improvement of 14% of sanitation provision in 17 years. Climate and rainfall. Research on the relationship between cholera incidence and climatic variability in Western African nations has revealed a synchronization between cholera outbreaks and local rainfall, as well as global climate variability that transcend national borders. This synchronization supports the conjecture that cholera is susceptible to climate on a much wider scale and is a common external factor across countries. In Dar es Salaam, Tanzania, 2017, robust evidence of a higher ward level occurrence in hospitals with cholera cases was found to be led by high weekly accumulated rainfall and flooding. In Africa Great Lakes regions, the abundance of phytoplankton lakes is directly related to augment in number of cholera cases. Rainfall play a role in it because increases the nutrients on lakes, promoting plankton growth, as well as expands fecal contamination on the water due to sanitation system overflows. This result explains the inland resurgence of cholera cases after long periods of non-cholera incidents. And for last, the economy. It's expected that a scarce economic resource to invest in infrastructure and health services will increase the vulnerability of countries to disease outbreaks. Aims and objectives of this study. Aims are to identify the main risk factors contributing to cholera's endemic's resilience in the sub-Saharan countries, and to provide an objective account of areas to be tackled to reduce cholera propagation and achieve a higher level of control of the disease in the region. The objectives are the identification of endemic cholera routes in the sub-Saharan region and common cholera propagation agents, and quantify the contribution of risk factors like poor sanitation, drinking water contamination, rainfall, and climate on increasing number of cholera cases. The methodology. Selection of variables and regions of the study. Countries were selected according with the availability and reliability of the data from the WHO reports on cholera cases. Risk factors selected based on literature review and contribution to endemicity of cholera. The selected risk factors were safe drinking water and sanitation provision, rainfall, temperature, and GDP. Data on water and sanitation provision for each selected country was sourced from the World Health Organization, UNICEF, and CEng. Data on cholera cases was extracted from the World Health Organization's weekly epidemiological records. Data on rainfall and temperatures were sourced from the Climate Change Knowledge Portal from the World Bank Group. Quantitative analysis, the relationship between variables, was analyzed using Pearson and Spearman's role correlation via the SPSS software. And the relative risk of cholera for each factor was calculated using a temporal time series linear model with Poisson distribution and log-link function. Because of the instability of the initial attempt's results, the entire data was separated in two sets. Set 1 containing all variables and water provision, and set 2 containing all the variables and basic sanitation improvements. So the selected countries. All selected countries satisfy the following criteria. Have consistently reported cholera cases for over 2/3 of the years between 1990 and 2019. Those are the years we collect cases from the World Health Organization. Because we have to restrict the countries, because when there is a gap of few years with no cholera cases in the data set, it's not possible to confirm if this is due to efficient control of the countries, therefore no zero cholera cases, or as a result of poor reporting practice, which is occurring in many countries, sometimes due to politics, sometimes due to the difficulties in collecting data. And the other factor is that countries that don't present epidemic episodes. So countries that did not have years where cases peaked to over 10 times the average number of cases for that country for the same period between 1990 and 2019. So the select countries are Benin, Burundi, Democratic Republic of Congo, Ghana, Ivory Coast, Kenya, Malawi, Mozambique, Niger, Nigeria, Somalia, Tanzania, and Togo. From our African partners from the Overcome project, just Zimbabwe is not included because of the huge spike in cases in 2008 and 2009. On the table here, you have the 18 countries selected through the first criteria of 2/3 of reporting of cases. But from those 18, 5 had to be excluded because they have peaks, years that peaked cases in over 10 times the average. So Zimbabwe is one of them, which had 2 years, 2008 and 2009, with above 60,000 cases, where the normal for Zimbabwe were around 1,000, maximum 5,000 in previous years. So this deviates the country's cholera cases for endemic profile. The correlation results. Pearson's is the most common test for correlation. And for all variables, basic water, sanitation, rainfall, temperature, and GDP, Pearson test results spotted significant relationship between the country's water provision, rainfall, and GDP levels with cholera cases, as you see marked in red here. But Pearson's is not the most adequate method. We did as well Spearman's row correlation. A Spearman's row correlation is better suited for correlations with non-normally distributed dependent variables. Our dependent variable here is cholera cases, and they are not normally distributed. So Spearman's is better fit to this study. And the results reveal a stronger connection between basic water availability and GDP with cholera rates. So for both tests, the negative coefficient, you see minus here, they indicate that the variable value increases as the dependent variable decreases. So the dependent variable is cholera cases. So if basic water increases, or the provision increases and GDP increases, the cholera will decrease. That's what we expect, and it's a very good result. And also for both tests, the significance of the coefficients, the significance of the relationships proved is very high. So these relationships were not detected by chance. And on the second one in Spearman's, a coefficient above 0.5 would be a very strong relationship. So the coefficients we found here are around 0.46 and 0.47 is very, very good. Because it's very close to 0.5, it means that is a strong relationship, is highly significant, and is as we would expect it. Basic sanitation, rainfall, and temperature fail to be spotted, but we don't expect that all variables would be founded as significant here, and we don't expect coefficients to be higher than that, because there's many factors play a role in cholera incidence, and therefore, we don't expect just one factor to pop out as a main factor. So the progress of water and sanitation provision, comparison with cholera cases reduction. Further analysis evaluate progress of water and sanitation provision along with the number of cholera cases in each country for the period of 2000 to 2017. So in this table, you're going to have the improvement on the first column, the improvement in water provision between 2000 and 2017, the second column, the improvement in sanitation provision, and in the last column, the reduction of cholera cases average between 2000 and 2017. And the results displayed on the table reveal a pattern in which nations with higher access to clean water and sanitation had a lower average number of cholera cases recorded over the time frame. A good example of that is Mozambique here. As you can see, have a very a great improvement in water and sanitation provision, and so had the highest reduction in cholera cases. Most of the countries follow the same profile. The more the improvement, the larger the reduction in cases, except for Somalia, that had a very high improvement in water and sanitation, but had also an increase in cholera cases. And in Somalia's case, it's a very specific case because the country's been under ongoing civil wars since the 90s. So as many other factors may play a role in this increase of cholera cases that are not related just to water and sanitation provision. So the next step of the analysis was the cholera risk analysis. And this we're doing for GDP and rainfall in this slide. And for GDP, the stratified model revealed practically no variation in relative risk, implying that this component had no effect on cholera risk levels in this analysis. This might be explained by the fact that most nations in this study are in the lowest income group. In impoverished nations, even while the increase in GDP might be constant, the impact of growth may take years to be seen in infrastructure improvements. Furthermore, economic development does not imply equitable income distribution, and the advantages of a wealthier country might not be enjoyed by the most disadvantaged populations straight away. So what I mean is that the low variation, as you can see, the risk here, doesn't deviate much from one. One would be neutral, and lower than one is decreased risk, and above one is increased risk. The variation is very small, mostly around 0%, 0 point few, very low percent. The next parameter is rainfall. And the next steps of the analysis confirm the general notion that increased rainfall levels increase the relative risk of cholera. So as you can see, this is rainfall increase, and as you see rainfall increases, cholera cases increase as well. For few countries like Togo, Nigeria, Niger, and Kenya, the increase meant a decrease in cholera cases. And this, I speculate here, might be because those are very dry countries, and increased level of rainfall might provide other sources of drinking water that are less dangerous or less contaminated than the sources they used in dry seasons. It's just a speculation, but anyhow, the fact that cholera cases were gathered for the entire nation on an annual basis does not allow for a direct link with rainfall on the same basis, because it does not provide the precise location impacted by the rainfall events. So those two variables, GDP and rainfall, GDP because it varies very little, and rainfall because we can't, even though there is a relationship on this table, we can't exactly relate this to the increase of cholera to the rainfall because it's not located. There is no way to precise the location impacted by the rainfall, as we don't have the location impacted by cholera cases. The next is the relative risk analysis for set 1, which includes the improvement of basic water provision, impact on the relative risk of cholera. The estimated relative risk, cholera risk decreases under better access to safer drinking water for 9 of the 13 nations. So here in blue, you have the significant decrease of cholera cases with increase of basic water provision. And in orange, you have the increase of cholera cases for increments of basic water provision. BEng is neutral, so wasn't significant. The results found were not significant, so I have to ignore that. But the good result is that most of the nations followed, like If basic water is improved, the relative risk of cholera is decreased. And there is a considerable reduction of relative risk in 9 nations. It starts from the lowest proportion, about 4.2% here in the Republic Democratic of Congo, and reaching an average around over 30% on the remaining 8 countries. The remaining 4 countries, Burundi, Kenya, Somalia, and Togo, which revealed an increase in cholera risk. For Somalia's case, the results are not entirely surprising given the country's unusual behavior as a result of the ongoing conflict I told before. But for the other nations, however, there's not a clear explanation. This study speculates on the fact that Burundi, Kenya, and Togo were among the nations with the least progress in sanitation. Kenya even cut its services in the 17 years by around 4%. So it might mean that just improving water availability without adequate sanitation provision cannot lower the number of cholera cases by itself. The high population density is another element that favors cholera spread, and Burundi is one of the countries with higher population density in Africa and worse in wealth distribution. Nonetheless, it's recognized that while other underlying agents can impact the magnitude of cholera risk in specific locations, in any instance, each case requires individual analysis in order to allow specific connections to be established for these unexpected results in these countries. So the next one is the relative risk analysis for the set 2, with improvement of basic sanitation provision impact on relative risk of cholera. On this analysis, Togo and Burundi had no significant outcomes, and only 2 countries were found to be at higher risk of cholera, Somalia being one of them, and the other one is Benin. Where Benin previously had at least the least improvement in water supply and had no significant findings. So the remaining 9 countries again show a continuous pattern of cholera relative risk decrease with improved sanitation coverage, with some countries attaining more than 60% reduction of cholera, such as Niger and Malawi. Tanzania had the smallest drop, but it was still presenting approximately 10% lower risk of cholera. Sorry, I took a while to show the table, but basically, like, it's important to see that just 2 countries had a significant increase, and still one of the countries is Somalia. Benin before was not significant, so something might be unstable in Benin's data. And the other 2, Burundi and Togo, which are the same that had problems in the analysis before, are not significant here. So we can establish some kind of pattern here. The last variable was temperature, and the rise in temperature impacts on the relative risk of cholera. A strong relationship between temperature and relative risk is observed for almost every country, with the exception in this case of, again, Somalia and Benin, although both countries had very modest decrease, less than 7.2%. The remaining 11 countries had a considerable increase in cholera risk with increase of rainfall, ranging for at least 11% increase in risk. An explanation for the strength and consistency of these results may be related to the fact that temperature is not as location dependent as other variables. Temperature follows therefore the annual average of temperature data set encompasses the entire nation and a whole year at a time. Is the most closely related to the same kind of data set we had for cholera, which was also the whole year in the whole country. The findings on the relationship of temperature and cholera are also an indicator of the impacts of climate change in the region, with rising temperatures directly linked to an increase in cholera risk. This is a very important finding in this sense. It is still difficult to identify the causes of those other 4 nations' surprising outcomes. So here might be explained, as I said, water provision and sanitation might be because of dry weather or sources of water. But in general, the non-significant results for Burundi, Benin, and Togo, which can be the reflection of a quality and consistency of the data provided, which may also justify some of the results contradiction the expectations. So the conclusion of it is that from the findings of this study, it's possible to conclude that lack of clean water, inadequate sanitation, and rising temperature are factors contributing for the perpetuation of cholera in the Sub-Saharan Africa. Therefore, improvements in water sanitation provision must progress in order to control the disease incidence, as well as, of course, the control in temperature. But this is a matter that might be I step forward for studies in Africa. And although the other environmental factors did not present conclusive results in this study, its participation and importance on cholera outbreaks were not excluded by this research. The main limitations to find environmental factors correlation with cholera were related to poor data availability and quality. Hence, this study recommends that African and international organizations support the creation of a strong surveillance system in key health departments. The intricacy of the network of factors involved in sub-Saharan cholera incidence is challenging. However, if understood, it can reveal the easier and most efficient way to control the disease under the scarcity of resource faced by African countries. For future work, this work paves the way for several lines of future research, including the expansions to incorporate the examination of risk factors for epidemic cholera, with the inclusion of natural disasters, conflict zones, and other catalytic agents of cholera outbreaks, as well as investigation of appropriate risk mitigation strategies. That's the end of the presentation. I want to thank you for listening to me. And with these beautiful faces, I want to know if you have any questions.
Thank you, Cristiane.
Yeah.
There are a few questions which have come in the YouTube chat box as well as in the Q&A box. So let me put it up to you. The first one is from Omnia Ibrahim that has come in the YouTube. And hope you have seen it. That is, the climate change is the main core of the reason for being of cholera that can be faced by agriculture of green algae in the most polluted areas. And before that, he has also hinted that cholera can be removed from the sub-Saharan region by adding extract of DNA of some types of bacteria that can be extracted by photolaser system that are not harmful. Says the laser is strong. So these are two comments that have come.
No, I agree with Omnia comments, but that is more related to areas on the lake regions or in the coastal regions. So Africa has many lake regions, so where the algae might be a great influence and is a host in the periods in between cholera outbreaks. Sometimes you have months of cholera, non-cholera, and they are not exactly explained, but what is thought is that is in the algae that the Vibrio cholerae stayed for all this time until for some reason it starts to spread again. But it still is more related to these areas. Some areas are not close to lake regions, although lake regions and coastal areas are a factor. When they are not close to, other factors will play a role in it, and then not exactly you're going to exterminate cholera just for controlling the site. Can't hear.
Sorry. Another question from Elva Escobar. Can cholera be transported via coastal ocean waters?
Via?
Coastal ocean waters.
I don't know what he meant with also, sorry.
Coastal waters.
Oh, coastal waters. Oh, yeah. To be honest, a coastal border is a way of entrance of cholera. And they're being transported. It went to Africa in theory so far by transportation by army that came through continents and by boats and transportation. So all the coastal area, because of the movement and because of the water, the material that came attached to the ships, they are very vulnerable to cholera anyway, yes. And I did a study in Mozambique that I can't show it here at the moment, but it's very clear. The cholera in Mozambique itself spreads around the coast more than anywhere else. And they have a very big region lake where the cholera spreads a lot there as well.
Yeah, Elva Escobar has just written a clarification saying that what he meant was through ocean currents. Does cholera survive ocean salinity waters?
Yeah, so far what is known about it, yeah, it's possible to, and salinity levels even play a role. I didn't went through it because it's not exactly my field, but I read many articles that sustain salinity as a factor playing in cholera.
Oh my God.
Nandini's gone.
Sorry. Yeah. Another question from Ibinka. For the temperature factor, did you use average yearly measurements for the correlation calculation?
Yeah, the thing is, the biggest problem on this research was cholera data. Cholera data is many times not available for so variable reasons. Like in Africa, they have politics interests sometimes for tourist purposes, or for the sometimes the opposite. They would report even more, so they have aid coming to the country. So the cholera data itself was not easy to rely on it and to collect it. So in this phase, we got cholera cases per year in each country. And the same was collected for temperature. Even though we could have, by NASA data sets, we could have pinpoint rainfall and temperature for each station. They have many stations distributed through Africa. We couldn't relate cholera to the same station because we didn't have the data. So there was no point in doing so. And that's why the rainfall failed to find a straight correlation, because you can have a country as big as Mozambique, let's say. You might have a flood, you might have an enormous amount of rain, or a drought, a very serious drought, where people might even move out of the region and looking for scarce sources of water that might be contaminated. But you can't relate the cholera cases to exactly these incidents. So you can't properly say rainfall was the cause of it or the lack of rainfall, because we don't have the data saying this region had a very serious outbreak in that time. So unfortunately, we couldn't do this relation. And then there was no point in getting more accurate temperature data.
Thank you. Now, and the next question has to be answered by either Shubha or Milton. That is from Anthony Ekman. With the prevalent rate of cholera in Nigeria as indicated in the study, we are interested in organizing a media workshop to highlight the environmental factors. Can the ONWARD provide funding support for this and related advocacy campaign?
Milton, may I begin an answer? Can you hear me?
Yes, definitely. Go ahead, Shubha, please.
Okay. What I can answer is that in ONWARD, we had initially planned for some meetings, but in the end, because of all the travel restrictions that came because of the COVID pandemic, we had to change our plans around completely so that within ONWARD, we don't at the moment have funds for a big meeting. But what we have done is, if you are aware, there is a Living Planet Symposium organized by the European Space Agency. And that will happen next May. And within that symposium, we have proposed a session on human health and environment with as a special session. There is also another special session that deals with the capacity building required. There is no travel support within the symposium, but I believe the registration is free. And only yesterday we were talking with one of the co-chairs of the symposium, and we have asked for two things. One is to allow for online participation of people who can't travel. And there was also the idea raised that ESA is looking into whether they can live stream the sessions. So my immediate request is please submit abstracts to either or both these sessions. And all I can do, and all Milton and I can, all of us, we can only try to persuade ESA at the very least to live stream the sessions. I hope that will answer your requirement, at least partially. Would you like to add to that, Milton?
Thank you, Shubha. I would strongly agree with your suggestion. And I also suggest to Anthony to being registered into ONWARD, and you can keep talking, and maybe you can have a few meetings and organizing a kind of a virtual or an online workshop. Yeah. I think that also very feasible, and we'll be happy and glad to support and also do the networking with other specialists and people who could be interested in this subject.
Yeah, that is absolutely true. Thanks for that, Milton. Indeed, through ONWARD, we can try to, well, we can organize an online meeting, isn't it?
Definitely, yeah. That would be also my suggestion.
We can do that.
Maybe something more focused on the region, if not only Nigeria, which also very interesting to plan, maybe joining with other countries. That's why I mentioned having a few meetings before, but definitely you can organize such a workshop.
That's right. We don't have travel funds. I went in that direction, but this is an excellent idea.
And also you can count on Air Center collaboration with that. I think that makes a lot of sense.
Of course, thank you. While I have the floor, may I thank Cristiane for a very interesting presentation. It's made us all think a lot, I think. The problem is so complex.
Yeah, the thing is, there is so many other factors. But because of the data itself, is not easy to make a correlation. But we know how many factors do play a role in it. And it's such a simple and at the same time complicated problem to solve, you know, because it's related to basic infrastructure and basic provision for the population in many cases. This endemic cholera, the endemic cholera will come very often, and it will come regularly to countries. I didn't approach the epidemic cholera because Africa is still suffering exactly with endemic cholera. And this, I think, is a more easier solution. It's like if you just improve the provision of water, sanitation, and keep an eye on temperature, this kind of things. The epidemic cholera would be more complicated because this is about disaster, it's about conflicts, that there is politics, there are other things involved. The other facts, but if you could at least do the basics for avoid the endemic that will come recurring every year, would be a great step.
Indeed, certainly, yeah.
Isn't it?
Thank you.
I'm gonna have to leave the session, but I'm really interested in the ONWARD program and the work you're doing, and I will be very happy to attend any other session. And I really just to watch it many times. I think I'm gonna do my inscription and come to see you again.
Yeah.
Thank you very much. Yes.
Yeah. Before you leave, there is one more question from Philippi. I cannot see the question here. Philippi, can you ask it directly?
Nandini, may I jump forward? Yeah, he was asking, Felipe Leal was asking from Brazil, he was asking if the algorithms that you have used in your study, if they are already available or if you could make it available. I know that Felipe is trying to move this procedure forward and so on.
Yeah, or can just contact me. I can provide, you can provide my details to Felipe, and you can just contact me. I can provide it for him, and we can discuss anything forwards. It's fine, no worries.
That's very kind. Thank you very much.
Thank you. I'm very happy to be with you today. Thank you.
Thank you very much, Cristiane.
Bye-bye. Hope to see you soon.
Yeah. Thank you, Cristiane.
Bye, Cristiane. Thank you very much.
Bye.
Thank you.
Taking the opportunity, Shuba, would you like to make any comment about your previous studies related to cholera in India, maybe?
That's a big topic, but I think what we are finding, if maybe Nandini and Anas can also add, is that, like Cristiane was saying, it is a very difficult problem. But in our experience, and there are factors such as cholera, such as phytoplankton concentration in the water that seems to be associated with cholera bacteria in the water, or at least Vibrio cholerae bacteria in the water. So perhaps the other point that occurs to me is that in the part of India we have looked at, which is Kerala, there is a strong seasonality in the events. So it seems to work better if we have finer resolution data, both in time and in space. And that is precisely what Cristiane is struggling with in the African situation, very difficult to get the data. So that, I think, is also a problem in India, to get reliable diseases data. In that respect, Brazilian databases seem to be much better. At least, comparatively. India also puts a lot of effort into putting data out, but at the moment they are in PDF form, so to collect the data from those sites is very hard. Anyway, I will stop at that point.
Yeah, very good. I would like to hear from Anas as well, but just let me make only one comment. Is it true, as Shuba mentioned, that in Brazilian database, you have room for filling in location information, but that's still an issue because people, they do not still don't work with coordinates, but at the most they work with addresses. And in the rural areas, in the remote areas, this means close to that river, to that lake, still like that. So, and that's I would recommend people who are interested in this subject to see the presentation, the webinar presented by Ricardo, was mentioning a package of open softwares and tools for gathering this type of data. And so I think this will be a very interesting effort locally, if we could do it, and sharing this expertise and making those tools available for the people for collecting information, a kind of citizen science. But then I'll move forward and leave the floor open for Anas, maybe Grinson, if he wants to comment, please.
Thank you.
Thank you, Milton. The data collection is actually major difficulty. It's not collection. The thing is, mostly this decisions are made based on the symptoms. So that differentiating diseases based on, so for example, cholera and acute diarrheal diseases, it's all based on the symptoms it is made. But local level and scientific investigations on the abundance of pathogens, of the environmental reservoirs of pathogens are important. Mostly that is the problem. So the environment to disease outbreak connectivity has to be established in a more better way. That is one thing which I found as a problem when we analyze data, environmental data. For example, we can get a better correlation between the rainfall and fecal contamination in the Indian conditions. That is quite similar to the correlations with Cristiane is getting reporting on the Vibrio cholera incidents and rainfall. So, such type of, correlations and environmental observations are very important to sort out the problem. Yeah, that's all.
Thank you very much, Anas. Yes, you mentioned a few interesting points. I would agree, but I'd like to know if Grinson would like to make a comment.
Yes, supplementing to what Dr. Anas said, knowing the disease is a crucial thing. Basically, different states in India have different level of public health system. But since we are working on Kerala is having a comparatively better infrastructure or better grassroots level information coming into the system compared to other Indian states. The local governance at the grassroots level is called a ward. So for each ward, there is an assigned health worker named Asha worker, ASHA, Asha worker. So these are the people who are basically collecting such information. Apart from the information what we are receiving in ONWARD project, I think Dr. Nandini is going to plan for a proper mobile application, which will be coming soon in the Google Play Store, for the ASHA workers to enter the data, and we will be in receipt of that data. So that will make a robust database, and this will be a sort of citizen science application, because all the ASHA workers may be connected to this mobile application, which is acronym as CLEANSE. I think Dr. Nandini will be the best person to answer it, because this time the citizen science program of this part is taken care of by her.
Yeah, if we go on discussing like that, it will go on forever. Yeah, because since we don't get a correct sanitation, we don't have a correct sanitation database, it's up to us to collect the data and to compile and make a database in order to have a sanitation map, first of all, and then inform the authorities about what has to be done. And another thing, apart from what what we understood from Cristiane's talk, is that in addition to the usual environmental variables which we test or which we do with, there are also other extreme climatic conditions like floods, rain, heavy rains, thunder showers, then waterlogging, and maybe and also things like civil wars, like what she said in the case of Somalia. All these have an impact on the socioeconomics of the population, and also on the vulnerable section of the population, those who are below the poverty line, who are affected. So all these have to be taken into account, and that's exactly what we mean by this ONWARD network. So those are all of you who are interested or who have an interest in working with any of these, or who have data on or access to, or who are working on any of these aspects, please join the network and add to our knowledge on these. and let us build it together into a dynamic database.
Nandini, there is a comment in the chat box from Carmen Lara, and she said that data collection should be harmonized between the countries. And I know that there are some protocols from the World Health Organization, and many countries follow that. However, just mentioning Brazilian experience and talking with colleagues, researchers, and working in the field, that there are some issues with how the protocols are being followed, about how reliable the informations are, and so on. And I think that having meetings, more meetings, and taking opportunities, you should try to discuss it more and formalize it, and then move it forward at the regional or country level first, because there are people interested in getting the best data that could be gathered. And of course, in a second step, even moving on to the World Health Organization. But without discussing this, pointing out what are the issues, maybe they will not be able to improve, as they don't know, maybe they are not aware of the problems. So that's our task, to make this contribution as well, I think.
Yes, what you said was also right. So let us all work together and organize more meetings. We are getting more and more focused with each webinar. And so we have now another thing to discuss about, that is a common protocol, that is data collection should be harmonized between the countries. That's also an issue to be discussed and come up with. So may I ask Shubha to give the concluding remarks so that we can close, or Katerina, maybe you?
I think it's better, Shubha.
There you go. Anyway, I would like to thank all of you for joining the session today. And I would like to reiterate what Nandini said. Please join the network formally. I hope you know how to become a member of ONWARD. If you don't know, please ask one of us. And then it's a small form to fill up, and then you become a member. And if you become a member, then we can stay in touch even after the project ends. ONWARD is a short project, 2 years. And we are already completing 1 year, or completed 1 year. So it will finish soon. But if we can have this network alive, then we can carry on many of these activities, because obviously this problem is not going to be solved in the next 1 year. So that's my first request. And then I'm thinking, when I hear these discussions, that perhaps next time we should organize a webinar with the idea of having a discussion around data collection at the grassroots level, or things like that. And maybe Ricardo can be one of the coordinating people, because he's initiated something like that for Brazil. If we can get the citizen science to work in a reliable manner, then we can go pan-country, right? We cut the governments out and we go straight to the information. But then it has to be reliable. And how do we achieve that? It's a good discussion to have. And let me just thank all the people again. And we will announce the webinar for the next webinar, I hope fairly soon. Please join us again. And thank you very much.
Just before closing, I want to say to the participants, basically these ideas were conceived by Professor Dr. Trevor Platt. We have started a foundation, Trevor Platt Science Foundation. The basic foundation website is also available. You can also be part of Trevor Platt Science Foundation, because per se, many of you will not be related to cholera or water-related diseases, but you will be interested in some of the concepts which have been developed by Professor Platt. So that may be of interest to you. So kindly look into Trevor Platt Science Foundation website and join there also. because your interest may be diverse, not specific to this particular subject. So we welcome you to that also. Thank you.
Thank you.